Here we go. Substitution practice problems. There are only 6 practice problems for y'all to do, so this should go quick. All right, we're actually going to, unlike the notes, we're actually going to solve through all of these and actually find those coordinates where these 2 lines are going to cross on the graph. So if you didn't see the part of my last video, you can actually download the TI-84 calculator onto your phones, and it will be a screen that looks similar to the one that I'm going to be using today to graph the lines and show you where they intersect. Okay, Desmos is also an option that you can use on your computer. All right, so number 1, here we go. So based on my notes, I noticed that this one has one equation that is set equal to a variable. Okay, I can see right here that this equation is set equal to x. Okay, that's really good news when we're solving for substitution, because then all we have to do is take what it is set equal to and substitute it in everywhere we see an x in this case, okay? Because that's what it's set equal to. Now, if it was set equal to y, we would obviously substitute it in everywhere we saw y, okay? So we're just going to take 3y minus 9, and everywhere we see an x, we are going to plug it in there, okay? So we're going to take my second equation, because that's the one that wasn't solved for a variable, and we're going to rewrite it with the other equation substituted in, okay? So I have 5. All right, now there's an x here, okay? I want to get rid of that x, okay? I'm going to substitute what x was set equal to. So everywhere I saw that x, I'm going to substitute 3y minus 9, okay? And then I'm just going to write the rest of this equation out. Minus 2y equals 7. Okay. So now, this is where we just stopped in the notes and I put now solve it. Now we're actually going to solve it, okay? Because we need that practice as well. All right. So first thing I notice is that I have this 5 out here on the outside of my parentheses. So the first thing I need to do is I need to distribute that to everything inside of my parentheses. Okay, so I have 5 times 3y. That's going to give me 15y, and then I have 5 times a negative 9. So a positive 5 times a negative 9 is going to be negative 45 minus 2y equals 7. Okay, so now I see that I'm going to have to combine my like terms. So I have a 15y and I have a negative 2y. So always look at that sign in front of your number to see if it's positive or negative. Okay, so I have 15y minus 2y. Okay, so that's going to give me 13y minus 45 equals 7. Okay, so then I have to combine my other like terms. I have a negative 45 and I have a positive 7 on the other side of my equal sign. So I need to get that negative 45 to the other side. Whoops. So how do I do that? I'm going to add it. If I do it to one side, I have to do it to the other side. So those 45s will cancel, and I'm left with 13y equals 7 plus 45 is going to give me 52. All right, I'm almost finished. Remember, the goal is to try to solve for that variable. We're trying to find that x variable and the y variable where those 2 lines are going to be crossing on our graph. Okay, so we're almost there. We got to get this 13 by itself, or I'm sorry, the y by itself. We got to get rid of the 13. So that's 13 times y. So I'm going to divide by 13, and I'm left with, well, those 13s cancel. Y equals 52 divided by 13 equals 4. All right, so a lot of you are going to want to stop there because we solved for a variable, but we only solved for one variable. We have to solve for both, okay? So since I know y equals 4, and I have an equation, and I have a variable, what am I going to do? Plug it in is what you probably are thinking, or substitute, okay? So at this point, you can choose any of the two original equations that you want to choose, okay? I'm just going to choose the first one. Doesn't matter which one you choose. You will get the same answer. If you don't believe me, you can try it. So I have x equals 3y minus 9. So I have an equation. I know what y equals, so I'm just going to plug it in. So x equals 3 times y equals 4, we just discovered, minus 9. So x equals 3 times 4 is 12, minus 9, x equals 3. So if we were to graph these two lines, then they should intersect at the coordinate 3, 4. All right, I'm not going to do this with all of them, but just so you can know how to check your work. Now, I want to see all of this work, but you can use Desmos as a way to check it, okay? So you can't just put the final answer because I want to see all of the work. Okay, so we could go back to the beginning and we could graph x equals 3y minus 9. We could graph 5x minus 2y equals 7. Okay, so we can see that those two lines intersect. We have this blue line and this red line, and they intersect right there at 3, 4, which is what we said over here. Yay. So you can always use Desmos as a way to fact check your answers. All right, next. We've got number 2. Okay, so once again, I see that I have an equation that is set equal to, I have one equation that is already set equal to a variable, which is really good for us. Okay, so that means we just take all of that it's equal to, and we're just going to substitute it into the other equation where we see that variable. Okay, so this time it was the second equation that was solved for a variable, but nothing changes. I'm going to take the other equation, I'm going to rewrite it. So I have negative, I'll write it smaller, negative 6x plus 3, and since that's a y, I'm going to replace it with what y equals, which is 2x minus 4, and that equals negative 12. Okay, so that's the only part that is actually substitution. The rest is just simplifying your equation. Okay, for some reason these pins are just writing so skinny. Okay, so now if you want to pause the video, try to simplify this yourself and check where you check and see if you got it right, or check where you make mistakes. That's going to be good practice for you, okay, because you can always play the video back and check. All right, so what I noticed next is I have this 3 that I need to deal with before I can continue solving for anything. So I need to distribute that 3 first. So you might want to make you a little note to just remember to distribute first. That needs to be your first step. Okay, because that's 3 times all of y. So we need to multiply out that 3 first. Okay, so I'm just going to bring my negative 6x down just so I don't forget it. So then I have a positive 3 times a positive 2x. So that's going to be a positive 6x. All right, and then I have a positive 3 times a negative 4. So that's going to be negative 12. And that all equals negative 12. Okay, so then I can see that I can combine these two terms over here. Team timeout. Just kidding. I'm getting ahead of myself. Erase that. Mark it out. Sorry if you're using a pen. Don't hate me. All right. So the first thing I noticed is that we can combine our like terms. Sorry, guys. So I have this x and I have this x. Well, if I have a positive or a negative 6x and a positive 6x, those are just going to cancel out. So then I'm left with negative 12 equals negative 12. Okay, is that a true statement? That is a true statement. So this one's going to be a little different, and you're going to see why. Okay, so let's see what happens when we graph this one. So I have negative 6x plus 3y equals negative 12. All right, so first thing I want you to notice is that I'm looking at a green line here. Okay, now watch what happens when I type in this other line into it. Okay, first I notice I haven't typed all of it, but I have a parallel line, and then I do -4, and that green line has now turned purple, meaning that it's the same line. Okay, so there's not actually just one point where they cross. They're touching and they're crossing at every single point. Okay, so this one's not going to have one specific answer that it intersects like in the first one. This one is actually going to be, it's going to have infinite solutions. Okay, so if you get like a funky answer, it's always good to graph it and just maybe think about why. And I'm sure that probably rung a few bells for a few of y'all when we did that back in class. If not, then you heard it here first. Next. All right, so this is number 3. Now, first thing I noticed is that neither one of these equations here are solved for a single variable. So that means our first step is going to be solve for a variable. Okay, so again, it doesn't matter which one, it doesn't matter which equation. I usually just use the first equation and solve it for the variable. Actually, after looking at it, I see that this y is already by itself, so that one would probably be easier to solve for y. Okay, so I have y minus 3x equals negative 13. So I want to get this y by itself. So I need to move that negative 3x to the other side. So I'm going to add 3x, add 3x. Those will cancel. I'm left with y equals negative 13 plus 3x. Now remember, I can't combine these two things because they are two different terms. Okay, so now this is what I am working with. So now that I've solved it for a variable, I can just substitute it. Okay, so since I solved this one for y, then I'm going to have to substitute it into this equation up here. Okay, so I'm just going to start off by rewriting it. I have 4x plus 5. Now, there's a y here. I'm going to replace it with negative 13 plus 3x equals 11. Okay, so now we're just going to solve it. Now, again, the reason all of this works is because now I have an equation that only has one type of variable in it. It just has x. Okay, we can't solve these two up here because they have an x and a y in the same equation, and we don't know what either one of those variables are equal to, so we can't solve it. Okay, so this is why you have to solve it this way. Now, again, we have to remember to distribute this number on the outside of our parentheses first. Okay, so I'm going to start off, I'm just going to bring down that 4x so I don't forget about it, and I have a positive 5 times a negative 13. Okay, so that is going to give me a negative 65. All right, and then I have a positive 5 times a positive 3x. That's going to be a positive 15x equals 11. All right, then I'm going to combine my like terms. Okay, I have a 4 and a positive 4x and a positive 15x. So that's going to give me 19x minus 65 equals 11. All right, then I'm going to move this negative 65 to the other side. So I'm going to add 65 to both sides. All right, so those 65s will cancel out. I have 19x equals 76. Divide both sides by 19. That cancels out. And I'm left with x equals 4. Now, again, a lot of you are going to want to stop here, but remember we're looking for that intersection point. Okay, so we have to find what not only our x equals, but also what our y equals. Okay, so I'm just going to, you can again go back and choose any one of the original equations that you started with, but this one's already solved for set equal to y, so I'm just going to plug all of that into it. Okay, so I know that x equals 4. Whew, nailed that. So y equals negative 13 plus 3 times 4. I just simplify it. Y equals negative 13 plus 12. Y equals negative 1. All right, so the point where these two lines will intersect on the graph is at 4, negative 1. Now again, if you wanted to check, you could graph it on Desmos. Now again, you can't just graph all these on Desmos and then put what the intersection point is, because I want to see all of the work, okay? So don't do that. Okay, next problem. Again, this one is not solved for a specific variable, so we need to do that. Oh my goodness. Okay, so we can just take this equation here. Oh my goodness. And we're going to solve for a variable, okay? Just to change things up and show you that it doesn't matter which variable you solve for, I'm going to solve this one for x this time, okay? So I'm going to move my y to the other side. So I have x equals negative 5 minus y. All right, so now I know that x equals all of that. So in my other equation, everywhere where I see an x, I can just substitute it for negative 5 minus y. So remember, you have to plug it into the other equation from the one that you solved for the variable. Okay, so let's start by rewriting it. So I have 4x minus, just kidding. So I have 4, and I'm going to change or substitute this x, and I'm going to plug in what all x equals, which is negative 5 minus y. And then I'm going to just finish the rest of the equation. Minus 5y equals negative 20. All right, then I have to remember to distribute this number on the outside of my parentheses. Okay, so 4 times negative 5 is going to be a negative 20. 4 times a negative y is going to be a negative 4y. And then I'm just going to rewrite the rest of my equation. Okay, then I'm going to combine my like terms. I have a negative 4y and a negative 5y. So I'm going to bring down my negative 20. Negative 4 minus 5. Just to be safe, plug that into your calculator. Negative 4 minus 5, negative 9. Negative 9y equals negative 20. Right. So then we are going to take this, and I have to get that negative 20 and combine it with this negative 20. So I'm going to add 20. Add 20. Those cancel out. And I'm left with negative 9y equals a negative 20 plus 20 is going to be 0. And then our last step is we still have to get that y by itself. So we're going to divide both sides by negative 9. And then 0 divided by negative 9 is just going to be 0. Okay. Now remember, we still have to solve for our other variable. So I'm just going to take that equation that we solved for x earlier, and I'm going to plug in or substitute 0 for y. So x equals negative 5 minus 0. Whoops. Okay. So negative 5 minus nothing is still negative 5. Okay, so if we were to graph these two lines, they should intersect at negative 5 and 0. That would be its solution. Boom. All right, 2 more problems and then we are finished. All right, so just like in our notes, these are the ones that are both equations are set equal to a variable. So when they're both set equal to a variable, then if we know that x and x both equal this, then that would have to mean that these also both equal each other. So anytime you're in this situation in any math problem ever, then you can just take your equations and set them equal to each other. And now you are left with an equation that only has one variable in it. So we can solve it. Okay, so our goal after we set them equal to each other is to get all of the variables on one side of the equation and all of the numbers on the other side of the equation. Okay, so let's do that. So I want to get this y here and I'm going to move it over here. Okay, it doesn't matter which side you put the variable on, you just have to get them to one side or the other side. So I'm just choosing to do, to move this y, this y over here. Okay, so 3y minus 1y, that's going to give me 2y minus 6 equals 2. Okay, so now it's looking more familiar to how you're used to seeing an equation. Okay, so now I've got to get this 6 and I got to move it to the other side with its like term. So those 6's are going to cancel. I have 2y equals 8. I'm going to divide both sides by 2. And y equals 4. Okay, not too bad. Now, again, you have to solve for both variables. Okay, so I'm just going to choose an equation. This one looks easier. So I have x equals y plus 2. Well, I know that y equals 4. So x equals 4 plus 2. So x equals 6. So if we were to graph these two lines, then they should intersect at 6, 4. Okay, and again, you can always check that on Desmos. Last one. All right, both of them are set equal to y. So if it's set, they're both set equal to the same variable, has to be the same variable, then you can just set them equal to each other. Now I'm just gonna tell you that this is gonna be one of those ones that come out with a weird answer, so we are gonna graph it. All right, so again, we have to get our x's to one side, our y's to the other side. Let me see how I did my notes. Okay, so I'm going to take this 2x and I'm going to subtract it from this side. Okay, because I'm moving all my x variables to this side over here. So that cancels. 2x minus 2x, that's going to be 0. Okay, so then all I'm going to be left with is 5 equals negative 5. Now, I can't really move it to either side. I could add 5 over here if I wanted to, and that would be 10 equals 0. Okay, but we know that it doesn't equal 0. Okay, so this one is one of those weird ones that come out with like a weird answer to it. So let's graph it and see why we are getting a weird answer. So again, the solution is that point where they intersect. So why are we getting a weird answer when they're supposed to be intersecting? Okay, so let's look. We have y equals 2x plus 5, and then we have y equals 2x minus 5. All right, what do you notice about those two lines? They're parallel. They are not ever going to touch or cross, in which case that would mean that your answer is no solution. Boom. And that is the last one. All right, I hope this was a good review for you. Make sure this is the last assignment for the week. So if you get this done Wednesday, then that is the only thing that's the last thing for the week. I may post a Google form just to kind of touch base with y'all. It's not going to be a quiz. It's not going to be math related. It's just going to be kind of like see how you're doing. Okay, so be looking for that. And yeah, make sure you get it all submitted. Make sure your photos are nice and clear. Yeah, don't know what else to say. All right, good luck, guys. See y'all.